Hi, Physics 20s. I wanted to make a post about one of the pre-test questions, just because it's a little bit tricky, and yes, hint, hint, there's a couple questions like it on the test on Monday. So the question is the question dealing with a sled being pulled up a ramp. It's this one right here. And so I want to just walk you through the steps that you would do to analyze a question like this and help you see that once you start breaking it down, it's not that bad. So first off, it's a 15 kilogram sled. And if we start, it actually wants to know how much force the snowmobile must exert to accelerate it uphill. Okay. Now there's a clue here that we're not dealing with stationary friction. And that is the fact that it tells you the coefficient of kinetic friction and nothing else. Okay. The other clue, of course, is that it is accelerating at 2 meters per second squared. So it's definitely moving. Okay. So in this case, we're not going to worry about static friction. Although we would if it had just broken static friction, like if we were just pulling on it and we just get it to start moving, the amount of friction we would have encountered would have been static. But this is definitely kinetic friction. So it does tell us the angle is 25 degrees. And essentially that's all the information it gives us. So right off here, what we need to zoom in on is just the sled. Okay, so if we draw a dot on the sled, and then from that dot, if we identify the force of gravity straight down, from that dot, or close to it, I guess, we would have a force normal. Okay, and yes, the snowmobile itself is going to be exerting a force uphill. We'll call that the applied force. Okay, and there will be, because it's going uphill, friction will resist that. So friction will be downhill in this case, and that's going to be the force of kinetic friction. Now, anytime you have a mass on an inclined plane, you need to recognize that the force of gravity can be broken up into its perpendicular components, the force of gravity perpendicular, and then the force of gravity parallel. Okay? And chances are when you get a ramp like this, sorry, that's close to a 90, but that's a 90-degree angle, you're going to have to find the force of gravity perpendicular and force of gravity parallel. Okay, so before you start analyzing other aspects of it, if you see that, I would start there. Okay, so I've kind of done this a little bit quickly here, but the force of gravity on this, again, it's just the 15 kilogram mass. Obviously, we didn't learn anything about the Skidoo because it's not relevant other than it's providing the force, but we don't need the mass of the Skidoo. So the force of gravity will be the mass of the object times the acceleration due to gravity, which would be 9.81 meters per second squared. And I've kind of already done this a little bit, so I'll just throw the numbers at you. It should be 147.15 newtons. Okay, that'll be the force of gravity. Now, because the incline is 25 degrees, then this angle right in here is 25 degrees also. And so I can find, maybe I'll keep that in blue for now, I can find the force of gravity perpendicular and the force of gravity parallel by using sine and cosine. So the cosine, the cosine of 25 degrees multiplied by the adjacent value will give me the hypotenuse. So our shortcut, if you remember, this would be the cosine of 25 degrees times the hypotenuse. Okay, now I didn't show all that here, but I'll give you another number. This one should be 133.36. newtons. Again, try not to round anything because this is all as best you can until the end. The sine times 147.15. The sine of 25 degrees, that one should be 62.188. Okay, so really something you should catch is that the force of gravity parallel, we could and we should also draw it right here. Okay, that force of gravity parallel, because if we look at our forces, the normal force and the force of gravity perpendicular are going to be equal and opposite to each other. So really, the only forces that we are concerned with are the forces that are in the horizontal plane. Those are the forces that are fighting each other and that we have to consider in terms of how much applied force do we need going uphill. Okay, so I'm going to move over and make some space so that we can see what we need to do next here. So I'm just going to kind of write it over here. What we have to see is that the forces that are up and down here, they have to add up to the net force. Okay, they are going to produce a net force. We have one force uphill and two forces downhill. Okay, this is about as hard as it gets. So the net force then is going to equal the force applied going uphill plus the two forces downhill. So that's the force of gravity parallel plus the force of kinetic friction. Now I'm writing it like this because I'm just getting a total force here. What you should note is that the net force is really going to be uphill. So depending on how you decide to orient it, I think it's easier, my brain works easier if I say that that's positive. So we'll say that the net force has to be positive because the sled is going uphill. The applied force is positive, it's going uphill, but we'll say that the negative would be downhill in this case. So the force of gravity parallel should be negative and the force of kinetic friction should be negative. Okay, so there's another way you can account for that, but hopefully this way will help you make sense of it. So we already know the force of gravity parallel. I figured that out earlier. What we need to get is the force of friction. Okay, and we can get that force because I've already been given the numbers for that. But you don't have them until you've broken up the force of gravity down. So what we need is the normal force. Okay, so the force of kinetic friction is equal to the coefficient times the normal force. The coefficient is 0.14, and the normal force is equal and opposite the force of gravity perpendicular. So that's 133.36. Okay, giving us a grand total of 18.6704 newtons. Okay, so that force, this force here, will now go up here. Sorry, that's a little bit off screen. The force of gravity parallel we already know, and the net force. Now the net force, it says that everything is accelerating uphill at 2 meters per second squared. So that means then that the net force will be equal to the mass, which is 15 kilograms times 2 meters per second squared. So 30 newtons uphill has to equal the sum of the applied force plus the force of gravity parallel, which in this case is a negative 62. Okay, we haven't really used that one yet. And then the force of kinetic friction, we calculated that to be 18. Now, some students can see this without making the negatives, but I like to show that so you keep track of all the direction. So really, you're going to combine these two together. And then when you move them over to this side, you actually have to add them because you're subtracting a negative, okay? So I'm hoping you can see to do the answer from there. That's probably as much as I'd like to show you, but I will post further videos for additional questions as they come in, but I'm confident some of you will want to see that one explained.